Hello, welcome. Let's try to solve another Leetcode problem. 1537 get the maximum score. So we are giving two integer arrays, nums1 and nums2. So nums1 is sorted in increasing order, and nums2 is sorted in increasing order as well. So for example, nums1 is 2, 4, 5, 8, and 10. So nums2 is 4, 6, 8, and 9. So we're going to traverse the current array from the left to the right. So we can traverse from the nums1 or nums2. Yeah, it doesn't matter. So if you are reading any value that is present in nums1 and nums2, you are allowed to trace your path to the other array. So only one repeated value is considered in the valid path. So this means if there's a common value in nums1 and nums2. So first of all, nums1 and nums2 are sorted in increasing order. So if we find this one and this one, this is a common value. So it means from here, this is nums1, we can go to nums2. But only one value is counted. So only one of the number 4 is counted. So for example, this is 2, 4. So only this 4 is counted, or only this 4 is counted. Yeah. So the score is defined as the sum of the unique value in a valid path. So for example, this valid path is like 2 to 4 to another 4, 6, 8, 8, and 10. So only common values can shift from nums1 to nums2 or nums2 to nums1. But after that, all those values should be sorted in increasing order as well. So we're going to return the maximum score, as the result is going to be really big. So it's going to be a modular 10 to the power of 9 plus 7. In this example, 2 plus 4 plus another 4, we cannot do that. So we're going to plus a 6, 8, and plus a 10. So this is going to be the maximum value, which is uncertain. As the array's length is 10 to the power of 5, maybe we're going to consider, maybe we're going to use a dynamic programming, because this is 10 to the power of 5. And so what are we going to do? As the nums1 and nums2 is sorted, maybe we're going to use two powders to solve the problem. So we're going to start from this is nums1, we're going to start from here. For nums2, we're going to start from here. So this is a 2, and this is 4. 2 is smaller, so we're going to shift the pointer I. So this is pointer I, and this is pointer J. So why we are shifting pointer I? So 2 plus 4 is going to be a 6. So I is going to be here, and this is 6. But here we have a value of 4. This is from pointer J. Yeah. So as this is a common value, so for this one at this position, so the value is going to be 6 as well. We can update it to 6. So this is a dynamic programming. So up to here, 2, 4, it's going to be 6. And up to here, 2, 4, 4, it's going to be 6 as well. And then we're going to continue to check. So 6 plus 5, it's going to be 11. And here, because we're going to always check the smaller values first, because it's going to be in increasing order. Because 5 is less than 6, so we're going to use this 6 plus 5 is going to be 11, and then the I pointer going to be here, going to be 8. But here, this is a J pointer going to be here. So after updating this common number 4, J pointer going to be here. So as this 6 is less than 8, so we're going to update the J pointer. So 6 plus 6 is going to be 12. So this is the result. Yeah, and then J pointer going to be shifted to here. Now we have found a common value. We have found a common value 8 and 8. So this means we're going to update the value of maybe we're going to call it sum1 or sum2. So sum1 going to update it to 5, 8. It's going to be 13, and this is 6, 8. It's going to be this is 12, 8. It's going to be 20. And this is 11, 8, it's going to be 19. So we're going to choose the maximum value. From here, we're going to choose 20. And here, for nums1, for sum1, we're going to choose 20. For sum2, those are two variables. So we're going to update it to 20 as well. So now, the J pointer going to be shifted to here, and the I pointer going to be shifted to here. As nums J is less than nums I, So we're gonna update the sum2 first. So sum2 gonna 20 plus 9 is gonna be 29, and then the j gonna be updated to the next position. But as you can see, it goes out of the loop. Yeah, it goes out of the boundary. It means we're gonna stop the tag. But here we have a record of a value. It is 29. But here we left a value of 10. So this means what left behind is 20 plus 10. It's gonna be 30. And the final result is going to be 29 and 30. We're going to choose the maximum. It's going to be 30. Yeah, as you can see, it is like a two-pointers problem, but actually it is a dynamic programming. So we're going to use a dynamic programming to solve the problem. So we're going to prepare two variables. We're going to call it sum1 and sum2. So we're going to set it to 0. And we're going to use the two pointers, I and j. It's going to be 0. And then we're going to prepare a mod. It's going to be 10 to the power of 9 plus 7. Now we're going to start the while loop. So while I less than length of the nums1, or j less than length of the nums2. So we're going to update we're going to check. So we're going to check which one is the smallest number. So if nums1i is less than, we're going to always check the smallest number first, because it's going to be in increase order and we're going to get the maximum value. So if nums1i is less than nums2j, so this means for this example 2 is smaller. So we're going to update it to sum1. Sum1 going to plus equal to nums1i, and we're going to update the I pointer. And if nums2i is less than let me make it like this. And if nums1i is more than nums2j. So in this way, we're gonna update the sum2, gonna plus equal to the smaller one, j, and j gonna plus equal to 1. So what left behind is nums1i gonna equal to nums2j. This means we're gonna have the common value, this 4. If we have this common value, we're going to update the sum1 and the sum2 together, which is going to be the maximum of the sum1 and the sum2 plus any value. It is nums1i or nums2j. It doesn't matter because they are equal. Yeah. So from here, if we find common values, we're going to update them together. Yeah. So now, but what left behind, because we have the while check. While I is less than the length of the nums1 or j less than length of the nums2, this means we don't know from where we're gonna stop, because this is our while loop. So we're gonna update them together because we don't know. We're gonna update the sum1 and the sum2 together. So sum1 gonna equal to sum1 plus sum of nums1i, and sum2 is gonna be sum2 plus sum of the nums2 and j. So finally, we're gonna return sum1 and sum2. It's gonna be the maximum value modular the mod. So the maximum value is gonna be the maximum of sum1 and sum2. So in our example, the maximum value is 30. Yeah, so we're gonna choose this 30. Yeah, now let me just run it to check if it works. Oh, I forgot to update the value of I and j. That is why I think they're gonna be infinite loop. So let's just wait for a moment because there's an infinite loop. After updating the I and j, I think it's gonna work. So this is not okay. Let me check. It is not all. It should be and. We're gonna check them together. If it didn't meet all of them, it didn't meet, it means definitely one of them will, the index will go out of the range, and then we're gonna check it from here. Yeah, so it's gonna be add instead of all. Yeah, now I think it's gonna work. As you can see, it works. Now let me just submit it to check if it can pass. The time complexity gonna be O(n) because this is just a while loop, and there's only one loop. So the time complexity gonna be O(n) because there's a never go back. We are checking nums1 and nums2 together from the left to the right. As you can see, it's really fast. Yeah, I think that's all for it. Thanks for watching. See you next time.